Okay, so with that out of the way, now let's get into the real meat of what we're going to be talking about today, which is we want to eventually understand what would happen if you fell close to a black hole. If you got really close to a black hole, what's going to happen? And we're not going to be able to answer that question yet today because there's some stuff that we need to understand in order to answer that question. Namely, we need to understand the theory of relativity. Okay? The theory of relativity. All right. And this, of course, is the Einstein's big contribution to modern science, at least one of them, the main one. Now, before we even get into this at all, theory of relativity. We're calling it the theory of relativity. What does that mean? If we call it the theory of relativity, what does that mean about all the crazy stuff that I'm about to get into? Let me put it this way. Are we iffy about it, or are we pretty sure about it? Are we pretty iffy about it, or are we pretty sure about it? It's called a theory. We're pretty sure. Yeah, we're pretty sure on this. In other words, we call it a theory of relativity. We have seen all of these things happen. Remember, a theory is not something that's just an idea. A theory is something that is backed up by tons and tons and tons of evidence. So every crazy thing, we're going to get into some stuff right now that is totally, it's going to seem totally against your everyday experience. But we have seen these things happen, okay? We have direct evidence of these things. So, keep that in mind as we go through this crazy stuff. We know that this stuff happens. In fact, some of this stuff that we're going to be talking about is directly built into the functionality of your cell phone right now. So like right now, your cell phone is using relativity. And I'll explain how that works eventually. Okay? So, but what we need to do first is it turns out relativity is not just one idea. There's two main parts to relativity. And I've got them typed out right here. Here's the two major types of relativity, okay? We just got something going on. There we go. Two major types of relativity. Special relativity and general relativity, okay? Special relativity and general relativity. Which one of these does it seem like he probably came up with first? Which one does it seem like Einstein probably came up with first? Special relativity or general relativity? Based on those names. General would make sense, right? General would make sense. But it turns out when he first started figuring out relativity, he didn't call it special or general. He just called it relativity. And then later, he figured out that his first idea was just a small part of a much bigger set of rules. And so it turned out that the first type of relativity he came up with, in order to show that it was just part of a greater whole, he called it special relativity. So special relativity was actually the first thing that we figured out. And then later we figured out general relativity. Now, what is the difference between these two things? Well, they both talk about how the laws of physics work, okay? But they talk about how the laws of physics react to different situations, okay? Two different sets of properties. And special relativity talks about how the laws of physics react to things going different speeds. So if two objects go different speeds, what happens? Okay? And general relativity talks about how the laws of physics react to gravity. Okay? So different amounts of gravity. How does that affect things. So different speeds, special relativity tells you how that works. Different amounts of gravity, general relativity tells you how that works. Now, for the black hole situation, which is what we're ultimately trying to explain here, which one of these relativities seems like it's probably going to be more important for the black hole? General relativity or special relativity? If you were to take a guess. And remember, you're probably going to get some of these things wrong today, and that's totally okay. This is going to be some crazy stuff. Yeah, general. General relativity because of gravity. Remember, the weird thing about a black hole is that near that singularity, you're getting an extreme amount of gravity. It goes to an insanely high amount of gravity. So general relativity is going to tell us how black holes are going to work, what's going to happen near a black hole. But in order to understand general relativity, we got to understand special relativity first, because general relativity is based on, or is built up from, special relativity, and uses some of the stuff that we learn here. And before we move on and start talking about special relativity, because special relativity is what we're going to be talking about right now, do you guys see the easy way to remember which one is which one's speed and which one's gravity? Do you guys see, what's the easy way to remember which one's which? It's actually a super simple, like, elementary school kind of way. This is the way that I remember which one's which. Yeah. Basically, it's the first letters, right? It's the first letters. Special and speed. Well, actually, both of them have SP. SPE, actually. Whoa, I didn't just notice that now. But yeah, the first couple letters are the same. So special, speed, and then general and gravity. So if you forget which one's which, just look at those first letters. Okay, so now, for both of these, what we're going to do is we're going to talk about some ideas that it's based on, and then some results that come from it. So what is special relativity based on, and what are some results that come from it? And then we'll talk about what general relativity is based on, and some results that come from that.